Hi, my name is Rob Sipple. I'm the Geospatial and Numeric Data Librarian at Florida Tech's Evans Library, and I'm here today to introduce you to a JavaScript library named D3. For starters, D3 stands for Data-Driven Documents, and it's a JavaScript library used to create customized and interactive data visualizations. It's used in combination with HTML and CSS to create content viewed through web browsers. Before going into what makes D3 special, I would like to briefly provide some background. When I was first taught the basics of creating a website, I was told that if you wanted to include an image on your website, you needed to start by creating an image file containing that image, such as a JPEG or a bitmap file, and that file would be stored on some kind of computer drive. You would then start with the HTML coding for your website. You might first create some headers and some paragraphs, and then you need to insert some code indicating where the image file was stored and where it should be displayed on the website. And that was all very fine and well, but it did include some limitations. For example, if the underlying data for the image were to change or be updated, it would not be reflected in the image, which would stay exactly the same. If this were unacceptable to you, you would need to go to the application you use to create the image file, update the image, and then update your HTML code to incorporate the new image file. Then your image would be up to date again, at least for the time being. If somebody viewing your website found that the information visualization was less than satisfactory, for example, if it did not reflect the specific information they needed or represent that information in an optimal manner, they were out of luck. The image is static. It is what it is. And finally, images often respond poorly to zooming. The image quality of a lot of file types will start to suffer once you zoom in beyond a certain point. And D3 addresses these limitations. First of all, your D3 JavaScript code, which generates your visualization, is embedded with the HTML and CSS code. So the visualization is generated each time that you pull up the website. And if the underlying data for the visualization changes, the visualization changes accordingly whenever you open or refresh the web page. D3 data visualizations often provide the means for the viewer to query or otherwise customize the visualization. And finally, D3 visualizations rely heavily on SVGs, which stands for Scalable Vector Graphics. SVG images remain crisp and clear regardless of the extent to which you zoom. D3 was created in 2011 by this guy, Mike Bostock. He used to head up the New York Times group responsible for developing information visualizations. So let's take a quick look at one of his visualizations from his tenure at the New York Times. This is a visualization showing voting trends in individual states during presidential elections from 1952 through 2012. The timeline runs down the right side of the page. Each of the wavy lines running down the page represents a different state. Thicker lines are states with larger numbers of electoral votes. And if you hover over a line, that highlights that line and results in pop-up boxes with supplementary information. So there is an example of D3 providing interactivity. Now, Mike Bostock has remained involved with D3 since he first created it, and he maintains a gallery of examples of visualizations created using D3. So let's take a look at some of the visualizations on Mike Bostock's gallery page, starting with his smooth zooming visualization. I'm honestly not sure of the practical use for this visualization, but I just wanted to show it to you so that you see how those SVG images, which in this case are circles, remain crisp as you zoom in and out. Now let's check some other visualizations. This sequencing starburst visualization shows hierarchical data displayed in a radial form. And as you hover over the image, a breadcrumb path is generated above the figure, and detailed information is shown in the center. And now one more example from Mike Bostock. This is what he refers to as the Bollinger Bands visualization, and it demonstrates how the user can alter the contents of the visualization. In this case, the user can alter the number of periods over which the data is averaged, as well as the number of standard deviations shown. Now, while Mike Bostock is a particularly well-known name in the world of D3, there are lots of other people doing very useful work. This particular website shows a a gallery of examples from a gentleman by the name of Jan Holtz. Jan Holtz's gallery provides general categories of visualizations which you can drill down into to see detailed examples. And what's nice is that in addition to showing what the visualization looks like, he also provides the code used to generate the example. And by the way, Mike Bostock also does this in his gallery. And if you've done any coding, you might realize that one of the best ways to learn coding is to borrow and modify code developed by others that are already relatively accomplished and are already doing the kinds of things that you want to do. And one more example. This is a visualization incorporated in an article entitled "The Inside Scoop of Ben & Jerry's." And if you look at it, you see that the text of the article on the right side of the page is supplemented by visualizations which change as you proceed through the article. Some of the visualizations incorporate animations, while others have pop-up windows activated by hovering over elements in the visualizations. So now that I've shown you a bunch of fairly elaborate visualizations, it's time for a bit of a disclaimer on my part. The coding examples I'm going to show you today are not going to be anything nearly that fancy, and there are a couple of reasons for this. First of all, this is just an introduction to D3, and if I tried to explain some of the more complex examples, we could be here for quite a long time. And secondly, although I'm interested in coding and I hope to one day be highly proficient at coding, at this point I'm really more of a dabbler. As I mentioned before, D3 is meant to be used in combination with HTML and CSS. And there are a couple of ways of doing this. The first basic way is you can embed your D3 JavaScript as well as your CSS code within the HTML file. And that's illustrated on the top right of the slide. And the other option is that you can place your JavaScript and CSS code in their own files and then call those from within the HTML file. And that's illustrated in the box on the lower right. And either one of these ways is perfectly acceptable. And for really entirely subjective reasons, the examples that I provided in the following parts of this presentation use the first approach. That is, the D3 JavaScript and the CSS code are embedded within the HTML file. So D3 works by going through a data set, looking at the discrete pieces of data from within the set, and assigning those pieces to elements in the web page. And those elements can be all kinds of different things. They could be paragraphs, lines, shapes, etc. So just to get started, let's look at an example in which the data are assigned to a series of paragraph elements. And on the left side of the page, you'll see the entirety of an HTML file, including the D3 JavaScript code. Near the top, you need to indicate where to find the source code for the D3 library. In this case, I've parked it in a parent directory, but coders will often just refer to the website where the library is maintained. Within the body section, I started out by creating 3 paragraphs, which I named Stuff, More Stuff, and Even More Stuff. And then after that, we have the D3 JavaScript code, which takes up most of the rest of this file. It starts where it says script and ends up down the page where it says /script. The first thing we do in the JavaScript is to define a data set with 3 values, 5, 10, and 15. But from a D3 perspective, the action really starts with the block of code that begins with d3.select. If you look at this block of text, it might appear to be a series of separate lines, but it's actually a continuous statement. Beginning with the second line, each line in this code, in this block of code, starts with a period, followed by some terminology. For example, in this case, the second line reads, period data, open parentheses, data set, close parentheses. The lines build upon the preceding lines in the block by adding some additional action or specification. And you can keep tacking these lines on almost indefinitely, which is one of the reasons that D3 allows a very high level of customization. And I'm hoping that this will become more clear as we progress through today's workshop. In the block of code shown here, we start by selecting all the paragraph elements within the body of the web page. And as you might remember, we created those previously in the code. And having selected the paragraphs, we then access the data set in the second line. In the third line, we step through the data set, retrieving each data value and assigning it to a paragraph selected in the first line. The output for this is shown at the bottom of the slide. Instead of the stuff, more stuff, and even more stuff that were originally assigned to the paragraphs now display the pieces of data in the data set, which are 5, 10, and 15. At this point, I would understand if you're thinking this is pretty basic stuff and it doesn't seem to really justify some fancy JavaScript library. However, what happens if you have a disconnect between your number of elements, which in our example are paragraphs, and the size of your data set? In the example shown here, we provide 4 paragraphs, but there's still only 3 values in the data set. The output, shown on the bottom right, lists the 3 data values, followed by where did all this stuff come from? If we're looking to use our data for some kind of visualization, we probably don't want that. Where did all this come from? Conversely, in this example, we still have 4 paragraphs, but the size of the data set has increased to 5. In the output, the final value, 25, is nowhere to be seen. Since there weren't enough paragraphs to go around, it was essentially left out in the cold. Now, D3 has a way of resolving these problems. If you don't have enough elements, it uses the enter and append syntax to create more elements. And if you have too many elements, it uses exit and remove to take the elements you don't need and basically sends them packing. They just go away. So let's take a look at how this works. In this example, you'll see that initially, I don't even bother to create any paragraph elements. Instead, I add the enter and append syntax within the JavaScript code. Looking at the output, you can see that we have precisely the number of paragraphs needed to display the 5 values in the data set. Just to show that it works the other way around, in this case, we started by creating 4 paragraphs, although we only have 3 values in our data set. By using the exit and remove syntax in our JavaScript, the extraneous where did all this stuff come from paragraph is eliminated from the output. At this point, I think I may owe it to you to show you something that looks a little bit more like a typical data visualization. So let's start with this. This is nothing fancy. It's not interactive. However, it is a good respectable XY scatter plot. You might notice that the circles are different sizes. That's because they've been scaled to reflect the values associated with them. Our graph also has X and Y axes, which are always useful for reading data from a graph. And although you can't tell by looking at it, the numbers in the data set were generated using random number functions. Also, scaling functions were used to ensure that the visualization fully utilizes the space available on the web page without being so large that it won't fit in the available space. So how is all this done? Let's start by looking at the generation of the data set. To kick things off, on the first line shown here, we establish the data set as an empty array. We then establish the number of points, 50, that we want to have in our data set. The next 2 lines randomly select the upper limits for the X and Y values. And at this point, we enter a loop, which cycles once for each point in the data set. For each iteration of the loop, an X and a Y value are randomly generated. The math.floor function rounds the X and Y values down to the nearest lower integer value, and the dataset.push function adds the XY pair to the dataset. Since the ranges in the XY values are randomly generated, each time you refresh the graph, you'll see an entirely different graph. At the bottom of the code shown in this slide, we calculate the maximum X and Y values. As you will see, these values are used for scaling the axes on the graph. Now, what determines the size of the visualization? Here you can see that we declare the height and width of the work area, as well as a panning allowance within the area. Then we define a variable that when activated, will append an SVG, that is, a scalable vector graphic of the specified dimensions to the web page. We also have code used that scales the axes placed on the map. Scale linear refers to one of a series of axis styles that can be assigned to the plot. Domain indicates the minimum and maximum data values, while range refers to the space available on the web page. Nice adds a bit to the ends of the axes so that the plotted points don't get jammed against the edges of the visualization. The code at the bottom provides the means for scaling the size of the circles on the plot. We now get to work plotting the points. This block of code may look somewhat familiar from our earlier examples. However, we are now selecting and appending circles instead of paragraphs. Also, since we are now positioning our elements, that is the circles, our block of code now includes terms for indicating the horizontal and vertical positions of each circle, as well as its radius. These terms incorporate the scaling functions shown in the previous slide. And finally, let's look at the axes. In the code shown at the top of the page, we define the basic characteristics of the axes. Axis bottom and axis left are among the styles allowed by D3, while ticks specifies the approximate number of ticks to be provided. The code towards the bottom pins the axes to the visualization. If you look at some of the terminology, transform and translate are basically used to maneuver the axes into their desired positions. The call term activates the variables defined at the top of the slide. Now let's try a bar graph. So here's a pretty standard bar graph, and as you would expect from a bar graph, the size of the bars corresponds to the values represented. We did not include an axis, but we did label the bars to indicate their values. Also, if you look at it a bit more closely, you may see that the bars are different shades of blue. The larger values are a lighter shade of blue, while the smaller values are darker. This time, we have fixed data values. No more playing around with a random number of functions. Similarly to the scatter plot, we established the overall dimensions for the visualization. At least in a general sense, this resembles the previous examples of how elements are generated, except now, instead of appending paragraphs or circles, we are appending rectangles to serve as the bars on the bar graph. The X and Y attributes specify the horizontal and vertical position of the upper left corner of each bar. Since each bar must be to the right of the previous bar, the X attribute is calculated as a function of the index number of each individual datum, rather than its value. Y is a function of the datum value. Other attributes provided are the width and height of each bar, as well as its color. These are calculated as functions of the visualization's dimensions, the size of the data set, and the value of the datum. Since our graph also contains labels, we need to go through an analogous process for appending labels. And logically enough, we do this by now appending text instead of rectangles. Again, we need to provide X and Y attributes for positioning the text. And in addition, we need to provide some text-specific attributes, such as the font, the size and color of the lettering, and the text justification. So here we have another bar graph. The colors are a bit more varied than in the previous graph. However, the real distinction in this graph is that the user can add or remove values by clicking on the links at the top of the visualization. To allow this, start by defining the data set so that each value has a corresponding key value. Once again, define the dimensions of your visualization. When appending the rectangles for the bar graph, calculate the fill color as a function of datum value. Since each datum consists of both a key and a value, you need to specify the use of d.value to calculate the color. Within the HTML code, before the JavaScript code, create two paragraphs and assign identification names, in this case, add and remove, to the respective paragraphs. In the JavaScript code, define a function to be executed when the paragraphs are clicked. The first part of this function will retrieve the identification name corresponding to the paragraph that has been clicked. And as you'll see in the following slides, this is only the beginning of a fairly lengthy function. So after identifying the paragraph that was clicked, the function continues by executing an if statement. And it says, if the add a new value paragraph was clicked, a new key and a corresponding random value are generated, and this pair is added to the end of the data set. And if the other paragraph was clicked, it deletes the first key/value pair from the data set. Since we now have a different number of bars, and the maximum value may have changed, the horizontal and vertical scaling factors are recalculated. The rectangles for the bars are all selected, and where necessary, additional bars are appended. As shown at the bottom of the code selection, since the number of bars has changed, the bars' horizontal positions must be shifted using the transition term. Duration 500 specifies that the transition occur over a period of 500 milliseconds. Now you might remember the exit and remove syntax that I mentioned earlier in this workshop, and you haven't seen anything else since I first mentioned them. And these now appear to identify and remove any bars that are no longer needed because of a datum being removed from the data set. Again, this transition occurs over a period of 500 milliseconds. Okay, so all this time, since first identifying the specific paragraph that was clicked, we've been in the same function. As I mentioned, it's kind of a lengthy function. The function now wraps up by updating the labels on the bars, and this is done in a way that is generally analogous to updating the bars. Let's take a look at just one more bar graph. The thing that distinguishes this graph is that if you hover your mouse cursor over a bar, the bar changes color. As in previous examples, we append rectangles as needed to bind to data values. However, we now incorporate onMouseOver and onMouseOut functions. The first of these transitions a bar to orange fill when the mouse cursor passes over. The second function causes the color to revert to the standard color when the cursor is no longer on the bar. Both of these transition over a period of 500 milliseconds. I'm hoping this has made you curious to learn more about D3. Since I'm a librarian, I'm naturally going to encourage you to use some of the library's resources. However, there are also good resources available online. Just about all of the library's resources are in electronic form. To access them, go to the library website, and below the picture of the library, in the More Ways to Search area, click on the eBooks link. In the resulting search box, type D3 and then click on the search button. There are also lots of online resources. I found the D3 section of the Tutorials Teacher website to be helpful, as well as the D3.js graph gallery that we visited at the beginning of the presentation. Beyond that, I suggest just doing some Google searches for things like D3, D3 examples, D3 samples, D3 tutorials, and so on and so forth. And with that, I just wanted to say thanks for joining me today, and happy coding.